We're going to reflect across the line y equals x. C is on the line of reflection, so that's going to be C prime. Then B, remember we need a perpendicular line from B to the line of reflection. We went 1.5 squares, so we're going to go another half and 1, and this point is now B prime, and that's A prime. So our new triangle looks like this. If you want to know the coordinate rule for that, let's again just look at B. That point was originally 1, 4, and now it is 4, 1. So notice we flipped the x and y. X, y now goes to y, x. Now we're going to look at a harder example. So let's draw that line of reflection. We have -1 as the y-intercept, and the slope is -2, so it's going to go down 2 over 1, down 2 over 1, to there. And we can also continue it in the other direction, and so this is going to be our line of reflection. It's not going to be as easy as the last one. We can't just count the number of diagonals because these points don't go exactly in the middle of each square. -2 is the slope of the original equation. So that means that we need to find the opposite reciprocal slope, and that's going to give us the perpendicular line. If we made -2 into a fraction, it's -2 over 1. So opposite reciprocal, we need to change the sign. It's now going to be positive. And we have to find the reciprocal, so we need to flip the fraction. So now it's going to be 1/2. So we're going to count how many times we go up 1 over 2 until we hit the line of reflection, and then that's how many we're going to continue after the line of reflection so that the distance from each point to the line of reflection is the same. For A, we go up 1 over 2, and then we hit the line of reflection. So we need to go up 1 over 2 again, and that's A prime. For B, we go up 1 over 2, up 1 over 2. We counted that twice, so we need to go up 1 over 2, up 1 over 2, and that's B prime. And then for C, up 1 over 2, we did that once, so we're going to go up 1 over 2 just once. And that is C prime.